Solar energy, wind energy, and hydro energy are clean energies that produce electricity that is used, for example, to power a lamp. Solar radiation is transformed into electricity by a solar cell. In general, a solar cell is composed of silicon, which is a semiconductor material and belongs to group 14 of the periodic table of elements. The silicon is between the aluminium and phosphorus elements. Therefore, a silicon atom has 2 electrons in the first layer, 8 electrons in the second layer, and only 4 in its last layer. The last layer, called the valence layer, has the valence electrons. Each silicon atom has only 4 valence electrons. To attain a stable state, the atoms will be bound by covalent bonds. In this case, each atom will gain 4 electrons to result in a total of 8 electrons on the last layer. The foreign atoms are introduced into the crystal lattice to reach an unstable state. This is called doping. The implantation of the boron will lead to a lack of electron because the atom of boron has 3 valence electrons. On the other hand, the presence of phosphorus creates additional electrons. A solar cell is composed of 2 layers of silicon placed in close contact with each other. One layer was positively doped, the other layer was doped negatively. The contact fingers are placed above the solar cell. In addition, an electrical contact is placed beneath the solar cell. The upper glass layer serves to protect the cell. The region in between the layers is the most interesting region. At the interface of these 2 layers, the electrons and holes combine to give a rise to an electric field. This electric field prevents the movement of free electrons and holes. As soon as the rays of the sun strike the layers, the photons are converted as they pass through the layers into electron-hole pairs. If the conversion takes place in the electric field, the electrons move in the negative layer, and the holes, on the other hand, are directed towards the positive layer. The diffusion of the holes towards the positive region and of the electrons towards the negative region causes an imbalance. Electrons and holes want to restore equilibrium, but it is the electric field that hinders a combination of electrons and holes. To produce electricity, a connection must be made between the upper and lower layers. The electrons must pass through the external circuit to combine with the holes, which generates a current.